Hello everyone and welcome back to another math video. Today we're going to be looking at exponential growth and decay in word problems. So we're going to be looking at compound interest, half-life, and population growth. Just a reminder, this is the speedrun version where we go pretty quickly. If you'd like the normal version of the lesson, I will link that in the description below. All right, your Ricasso Recap starts now. Here's what you need to know before you start this lesson in 30 seconds or less. You should already be familiar with how to round numbers when it says to the nearest whole number, nearest tenth. Okay, we should know what that means. If you do not know how to do this already, I will link a refresher in the description below. All right, new lesson starts now. Here we go. So exponential growth and decay are very, very useful in the real life, okay? Everything from IV drips to the amount of fuel a rocket uses to abstract geometric art to economics and interest rates to the atom bomb, all right? All of these utilize exponential growth or decay. Okay, so let's see some problems. All right, if you want to pause the video so you can read this problem. All right, now that you've read the problem, when we talk about half-life, okay, this is an example of exponential decay because every 1 month, this thing gets halved, right? It's getting smaller. Decay means getting smaller. So after, we start with 6,080. After 1 month, we cut it in half. So 6,080 divided by 2 would be 3,040. And we're going to repeat this process because it wants to know how much will we have left after 4 months. So after the second month, we cut it in half again. We divide by 2. 3,040 divided by 2 gives us 1,520. Repeat, third year, 1,520 divided by 2 is 760. And I said year. In the month, fourth month, do 760 divided by 2, we end up with 380. This is the final answer. Now, there is a way to do this because what if it had wanted to know after 50 months, right? We're not going to divide by 2 50 times. So there's a shortcut here. The shortcut is this formula. It looks complicated, but let's look at it. It's not too bad. All right, the first thing we need is the starting amount. So how much did we start with? Well, we started with 6,080 grams. 6,080 grams. The next thing in the formula is multiplication symbol, parentheses. The B is the growth or decay rate. So how fast is this thing getting bigger or getting smaller? Well, in this case, it's getting halved, right? Cut in half. So we're halving it. And then the next part of the formula is the number of growths or decays. How many times does this happen in our problem? Well, in this case, it happens 4 times, right? Because it's 4 months. And this formula, right, if you plug it into a calculator, will give you the same answer of 380. All right, so this is the formula that we need to get familiar with because we're going to use it a bunch. All right, if you want to pause the video, go ahead and read this problem. All right, now that you've read the problem, this is talking about a savings account or a checking account, I guess. And we're making money, right, because this is interest, right? So this is a growth problem. Our answer should get bigger. Now, when it comes to percentages, you have to be careful because this is an exponential growth problem. On a growth problem, you're starting at 100%, and they're telling you that you're getting 5% interest. So we're going to add 5%, which is 105%. And now the last thing you need to remember is you can't use a percentage directly into a problem. You need to convert it to a decimal. So to convert to a decimal, we just divide it by 100. So 105% divided by 100 is 1.05. This we're going to use. So let's use our formula. Okay, starting amount, $1,000, times the growth rate here is 1.05. That's what we just found out. And the number of times that we're going to earn interest, okay, annually means every year. So we're doing this for 4 years, so this is a 4. If we plug this into our calculator, we get 1215.50625. But it said to round to the nearest cent. Nearest cent just means 2 decimal places, right? Because we're talking about money. So we need to round here, so our answer is 1215.51. $1,215.51. So if it's percentages, you have to pay attention to whether it's growth, and we'll look at a decay problem here next. All right, go ahead and pause the video if you want to read the problem. All right, now that you've read the problem, this is a decay problem, right? Because here we're losing air out of a tire. So we always start at 100%, and we're losing 10% every minute. So now we're going to subtract 10%, which is 90%. And again, always divide it by 100, so we can use it in the problem, which is 0.9, or 0.90 if you prefer. And now we use our formula. Starting amount, 1,060 kilopascals. It's the pressure. Times, what's our decay rate here, right? This is a decay problem, so that's 0.9 or 0.90. And how many times is it decaying? 4 times again, right? So if you plug that into a formula, you get 695.466. It does not say to round, so we will just leave it like that. And notice our answer went down, right? That should make sense. All right, here's our cool clock for today, which means that it is time for you to practice what you just learned. Go ahead and pause the video and try these 2 problems on your own. And when you're ready, you can unpause the video and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem here is the work. You should have gotten 5,600,000. Okay, growth rate, it's doubling, so that's why I put a 2 here. And then it happens 3 times because, yes, it happens every 41 years it doubles, right? So 41 years is 1. Then another 41 years is the second time that it happens. And then another 41 years, which is the 123, so 3 times total that it doubles. And for the second problem, here is the work. You should have gotten 988 because it said round to the nearest whole number. All right, that's it for today. I hope you all have a good morning, good afternoon, good evening, and good night.